part of our course on B01 data management. So open science has multiple different definitions, but the key aspects of it of making things open access, making all the aspects of a research, not just papers, but also the data sets, software approaches that we use, accessible to everyone. And we have a responsibility if we're funded by the URSOC to achieve that. So open access for the papers and data, and open data means that researchers should be able to access your data that have been published in your paper, and that should be in an accessible manner, reusable and reproducible manner. And you can facilitate that by using standard machine readable formats with a high level of metadata where possible. We should also have open methodology in terms of sharing methods, protocols, workflows, and that means studies are more easily replicated and validated. And then open source more refers to if you're developing software and tools that they're have open source license and allowing others to use, modify them, and so on. So open science is important because it means that your results, it's more clear about how you generate your results, and makes it more easy for other researchers to use your results. It supports collaboration and means that your results will effectively be more important in your area. It will accelerate scientific discovery and then also enhance reproducibility of research. So, like fair data, we're talking about making steps in the right direction in terms of adhering to the BBSRC policy, trying to think about how standard formats are relevant for your area, particularly ones that are machine readable. Would support that typically. And we want to think about how would we deposit our data in the relevant primary or secondary databases. Licensing is not typically too complex for our area, unless you're doing something particularly novel. And then what is important is definitely documentation and the metadata associated with your data sets. So how can we do this? For example, an easy example of this is dates. And we should use the ISO 86001 date standard, which is represented here, where you see the year, month, and day as the format. And if you put these at the start of your files, like this example here, that can make it easier to track when your analysis was done, and for others to find out about when analysis was done and the order in which things were done. So these are known, but maybe not communicated more widely, so people are unaware. So open science may not be always a priority in a lab, and that's an issue because it will actually kind of impair research in the long term. It also has issues relating to quality, data quality I mentioned before, and the integrity of shared data. And that can mean you spent a lot of time trying to figure out why something was incorrect. Uploading, you must use the standard nomenclature for your area, and if you're not using that at the start, that can create issues. And then we really need to think about incentives for researchers to share the data openly, and acknowledging their contributions that support the community, and that's becoming more common in the terms of a narrative CV rather than focusing around publications. For some people, they write code. Good code is like a good book. It's easy to read, documented well, well organized. It's unlike this minimal or zero manual steps. It's reliable in new contexts, so if it's going to deal with new data sets. It's composed in common languages that are common to many people, easy for others to use, and is accessible. GitHub is the standard. It doesn't necessarily need to be perfect or good enough, but it can be of an adequate quality that at least people understand what you're trying to do at that particular time. So that kind of concludes our part on open science. Please see our next video.